Good day and welcome to this last section of electrostatics. So this is the last section, and in this section we're going to be dealing with galvanometer. So this is the last section. We're going to be dealing with galvanometer and how it can be used as ammeter and voltmeter. So without wasting much of our time, we're going to be defining galvanometer. What's galvanometer? It's the basic meter for when you are measuring direct current. So it's the basic meter, the basic meter for measuring DC direct current. So if you can use it to measure this, if you want to use it to measure AC, you are going to use it along with a rectifier. But if it is normal galvanometer, it's only used to measure DC. So let me just put except it is used with a rectifier. So when it is used with a rectifier, that's when it can measure AC, alternating current. So this is direct current, AC is alternating current. So next on the line is I don't think we need much there. So how it can be used as ammeter and voltmeter. You can use galvanometer as ammeter when you connect it with a shunt resistor in parallel. So when if you want to use a galvanometer as an ammeter, you have to connect it in parallel using a shunt resistor. So multiplication is done by using a shunt resistor in parallel. Let's just write that. Multiplication is done by using shunt resistor in parallel. So and what does shunt resistor mean? It means a low value resistor in parallel. So when you are using and you know when we have resistors in parallel, we have different currents because the current that is coming from the initial stage is going to split. So we are going to have something like this. Yeah, let me just use this please. But like when you're having something in parallel, you have something like this. Then you have a current. You have a current flowing from here, the current also flowing. So I will say this place is I. So I will say yeah, this is the resistor of the galvanometer. This is the resistor of the shunt. So if this current flows from here, part of it will flow here and part of it will flow here. So that means I will have um the current of the galvanometer. I also have the current of the shunt. So when it comes here again, the current will meet again and becomes that total current. So what's that telling us? It's telling us that I is equals to Ig plus Is. So and from there you can prove some formulas because when we have our normal Ohm's law, we have V is equals to IR. But in this case now that we are having Ig and Is, we are going to also have you can see that we have Ig, we have Is, we also have Rg and we have Rs. So we have the current for both galvanometer and shunt. We also have the resistor for both galvanometer and shunt resistor. So our V will be Ig Rg multiplied by Is Rg. So that um is going to be equals to, so our Ig is going to be equals to this, is also equals to this. So you can either say it's equals to this, it's still going to give you the same value for the current. So when you want to use that as an ammeter, you connect shunt resistor in parallel. Now let me just complete this. For in series um you have same current in series. So you have same current, but in parallel you have different currents in parallel. So in series you have different voltage. It's going to be different voltage in series, different voltage, and here the voltage is going to be same. As you can see, it is same in parallel. So voltage is same. So and when you are calculating resistance in series, it's going to be the sum. So your RT will be R1 plus R2 depending on how it is long. Then for resistance in parallel, you can have it as the inverse sum, which will be 1 over R1 plus 1 over R2 and so on. I'm just managing our space here. So now we have done how galvanometer can be used as a meter. Now, how can it be used as a voltmeter? We are going to be connecting um, a high resistor in series. If you want to use a galvanometer, modification is done by using an high resistor. And what is that high resistor called? Multiplier. So modification is done by using high resistor, that is a multiplier, in series. Note, you are connecting an high resistor in series, but in ammeter you have to connect the shunt resistor in parallel. So there are two different entities. So what are we having here? If you are connecting in series, that is going to be something like this. So we have the resistor of the multiplier, we also have the resistor of the galvanometer. So and we have the current. You see that the same current will flow. So and if the same current is flowing, that means we are going to have two different. It's only the resistance that will what that will be in two form that will be different. So the if you want to calculate the equivalent resistance for this, it's going to be the sum. So our V is going to be IR. Since I is same, it doesn't have anything to do. But since we are calculating the equivalent resistance, we are going to be having V is equals to I into brackets Rm plus Rg. So that's just for the explanation. Let's go into solving questions. So moving to the question part here, I have to calculate the resistance of the shunt resistor. So needed to convert the milliammeter, giving a full deflection of this. So we have the current of the milliammeter, and that is milliammeter is known as the galvanometer. So I will say current of the galvanometer is 20 milliampere. So we have been given current and resistance of the galvanometer here. Resistance of the galvanometer is 5 ohms. What are we given again? We have to calculate the resistance of the shunt. Resistance of the shunt is what we are looking for. So and it gave us so ammeter is converted to ammeter, measuring the current of this. This is not the current of the shunt. This is the current, the total current. So it's going to be I is equals to 3. In order to get the current of the shunt, we are going to be saying I equals to Is plus Ig, because they did not state that that is the current of the shunt. So we just have to calculate for that. So using this is 3 here, because Is is what we are looking for, then plus Ig, which is 20. 20 times 10 raised to power minus 3. That's because of the middle here. So we're going to be having Is 3 over 20 times 10 raised to power minus 3. So that will give us, let me calculate that. We're going to be having 2.98 ampere. So this is our Is. So when we are getting our Is now, we can now use that formula, because we are using shunt resistor to convert galvanometer to ammeter. That is going to be in parallel. So and if we are doing that, so we are going to be having Rs equals to Rg. That is the voltage is going to be the same on this place. ISRS is either used that as V or use IGRG as V. So what's our Is? That's 2.98 multiplied by our Rs is what we are looking for. So our Ig is what here? Our Ig is 20 times 10 raised to power minus 3, then multiplied by our Rg, which is 5. So we can solve from there. If we solve that, our Rs is going to be this will come here, you have 20 times 10 raised to power minus 3 multiplied by 5 over 2.98. So, and that will give us from our calculator, we should have 0.034. 0.034 ohm. Moving to the second question, we're going to be calculating the resistance of the multiplier required to convert a millimeter giving a full scale deflection of 20 milliampere. So they have given us the current of the galvanometer again. So I will say current of the galvanometer is 20 mA. The current of the galvanometer is also the current of the multiplier here, because when you are connecting it in series, and in series current are the same, so I don't actually need to specify this. We are given the voltage here. The voltage is 10 volts, and we have to look for the resistance of the multiplier. So you can remember that formula. V is equals to I Rm plus Rg. So after that, you can continue solving. 10 equals to current is 20 Rm plus, what's our Rg going to be? That's what we are looking at. Our Rg is going to be 5, which is here. So you can open the bracket and say this is not 20, this is 0.02, because that is 20 times 10 raised to power minus 3. So that will be 0.02 because of the milli. So 0.02 Rm plus 0.02 times 5. So I can just make it fast and say 10 minus, if you calculate this, is going to be 0.1. So 10 minus, we are bringing it to the other side, it will be 0.1 over 0.02. And my Rm, when you calculate that, is going to be 495 ohms. 495 ohms. The reason why is that you are connecting I resistor value, which is a multiplier, so the value is going to be I. You are connecting it in series as we did there, so the value is going to be I. So this is the end of this session of electrostatics, the fourth part. Do well to like, share, comment and subscribe.